Machine learning versus human values. I'm Tonya Hall, and joining me is Brian Christian, author and visiting scholar at the University of California at Berkeley. Welcome, Brian.
Thank you.
Give us a quick summary of your writing history, will you?
Yeah, so my academic background is in philosophy and computer science. And so I've been, for my adult life, very interested in the many ways in which those two fields collide. And in particular, the question of what computing and what artificial intelligence teaches us about what it means to be human.
Your latest book, The Alignment Problem, Machine Learning and Human Values, just came out. Describe the problem of undesirable and unintended outcomes that you discuss in the early part of the book.
Yeah, so the term the alignment problem refers to this question of, in the field of machine learning, is the machine learning system really learning what you think it's learning? And are you really able to get your intention expressed as the objective of this statistical system? And if there's some gap there, then that's an alignment problem. And the system isn't really doing what you think it's doing. And this has consequences that range everywhere from what you might think of as ethical problems, issues of bias, issues of fairness, issues of transparency, all the way through to actual physical safety, cars that are unsafe to drive and, industrial robots being unsafe and so forth. And some people extrapolate that all the way out to existential risk and think about threats to humanity itself from super intelligent AI systems that are also in some way misaligned. We attempt to impart our norms, our values, but we get something wrong. And so this is an issue that's very central to the field of AI right now.
The evolution of machine learning and AI you document is one of progress, then plateau. Where are we in that cycle today?
I think we're at a very unique and interesting place where a lot of people have been kind of rightfully concerned. There have been a series of high-profile incidents with machine learning systems going wrong, whether it is, Google Photos mislabeling a photograph of a Black American as a gorilla, or evidence that there are kind of disparities in the way that systems are operating in the criminal justice sector to do things like parole and probation, to just about a year and a half ago, we had the first pedestrian killed by a self-driving car. So this has really created a new feeling of concern, both within the public at large and specifically within the scientific research community, that there's really something here that we need to pay attention to that's not just making the algorithms faster or more accurate or improving the state of the art on some benchmark, but there's a fundamental question here of, as I say, alignment that really needs to be thought through. And what I think is exciting about where we find ourselves now in 2020 is that movement has now started to begin. We've got a first generation of PhD students that are going up through the ranks, explicitly focused on this question of making machine learning fair, making machine learning safe. And those efforts are really starting to bear fruit. So we have a plan. We have a scientific agenda that's in progress and is making some early strides. And for me, it's exciting. It's kind of the beginning of a movement and the beginning of really a new field.
For the average person in society, how willing are they going to be about accepting machine decisions regarding important aspects of their lives?
I think getting that trust is critical, whether it is the system that determines, whether you're going to get a mortgage, or the system that determines whether you're going to be released on bail pending a, court hearing. There is a critical question of, I think, among many other things, transparency. Do we understand what the system is doing? And that is a huge area of interest within machine learning. Neural networks, deep neural networks, have this reputation for being black boxes, quote unquote. And some of the most exciting research to me in this area is figuring out ways that we can sort of pop the hood and visualize what's going on inside a neural network, or constrain a neural network to be more kind of legible to us in certain ways and without sacrificing accuracy. There's also a movement to use simpler models in cases where we don't need to use a deep neural network. We might be able to use something similar, again, without a huge accuracy trade-off. And doing so might be an important step in allowing people to feel comfortable with what exactly these systems are doing. And I think that's both an issue just for kind of public trust, but it's also an issue for safety. You know, you want to be able to look inside the network and say, has it in fact learned the things that I was trying to teach it and not something else?
I've been interviewing machine learning and AI experts for years about transparency and algorithmic bias. The experts are aware of the problem. Are they fixing it?
It feels to me like we're seeing very tangible strides in this direction. So, I mean, I can point you to individual strands of research. There's people like on the transparency front. There's people like Cynthia Rudin, computer scientist at Duke University, who has developed ways of harnessing the incredible computational boom that we've seen in the last couple decades, particularly with GPUs and so forth. Using that computational windfall not to train huge models, but in some ways do the opposite. Search through the giant combinatoric space of all possible simple models and identify the provably optimal simple model. And so that's a completely different way of putting that computational power to use. And she's able to identify, for example, extraordinarily simple models that would fit on, a single English sentence, or you could write it on a Post-it note that have competitive accuracy with some of the state-of-the-art deep neural networks, at least in certain domains. So I think that's really encouraging. You've also got people like at OpenAI, Chris Olah, who leads the Clarity team there, who's working on sort of reverse engineering the inside of deep neural networks that do computational vision. So you can actually inspect which parts of the image are activating which parts of the neural network, or what sorts of shapes is this network responding to in these different ways, and really trying to kind of take a little bit of the mystery out and show us visually what's happening on the inside. So those are just two of many, many researchers who are really making headway. So I would go so far as to say that the black box reputation that neural networks have may well be a thing of the 2010s. It may not be the case that going forward we think of them in those terms because we just have better tools.
But are we expecting technology to do too much? I mean, will machines ever be able to understand human nature, cultural differences, and local customs well enough to go beyond solving narrow problems?
That's a very good question. And there's a lot of interest within machine learning around this question of how do you impart something into a network that's so complex or subtle that you can't express it directly in code or directly in numbers. Or in reinforcement learning, you can't directly hand code the reward function because whatever you're trying to express is just too complicated. Is there still nonetheless a way to get that information from a human brain into the system? And the answer is yes. And there's, for me, one of the most encouraging results in this area comes from a collaboration between scientists at OpenAI and DeepMind working on this really charming problem, which is, can you get a simulated robot to do a backflip? And what's tricky about this is that it's very hard to specify numerically what a backflip is. It's this amount of rotational inertia on these, joints, it's these set of torques and velocities, et cetera. It's really hard to actually code that in. On the other hand, when you see a backflip, you recognize it. And so what they were able to do was create an interface where this simulated robot would do sort of random behaviors, and you would just pick, does the image on the right or the image on the left look slightly more like a backflip? And the software would then use your choices to try and make a guess about what it thinks you think a backflip means. And to make a long story short, after doing about 900 of these comparisons, suddenly the system is able to do these gorgeous gymnastic backflips, tucking in the knees and sticking the landing. And so that, I think, is a really encouraging test case that we can get some of these things, in this case, sort of aesthetic preferences, but just more broadly, human norms, human values, human preferences, without requiring the user to specify them in code or even in words. There's a long road ahead to extrapolate from backflips to all of the moral norms of human society, but I think it shows that there's some real promise here.
Brian Christian, visiting scholar at the University of California at Berkeley and author of The Alignment Problem, Machine Learning and Human Values. Brian, if somebody wants to find out more about your book, maybe get a copy of your book or find out more about the other work that you do, how can they do that?
You can go to my website, which is brianchristian.org, which has information about the book. And you can also find me on Twitter at Brian Christian.
Welcome to Twitter, Brian. Thanks again.
Thank you very much.
And find more of my interviews right here or at tonyahall.net. Thanks for watching.